Introducing a new super elastic multi-force arch wire technology. Hey everyone, I'm Dr. Sonia Palick from Woodstock, Ontario, Canada. I'm really glad you're here to learn more about this exciting new technology. Let's get started. Our key learning objectives with this brief webinar will focus on the biology of tooth movement, the factors that impact the stress on the periodontal ligament, the creation and fabrication of SmartArch, and also touch on the physiologic differences in our conventional nickel titanium wires versus SmartArch. I think you'll find this data really surprising. I know I did. So why do we need another arch wire? I've heard practitioners say that we can start treatment with anything really, and it makes no difference. We're just using a light brown wire to gently start moving the teeth and usually unraveling some crowding. But is that really what we're doing? And what if we could do more right from the start? Let's look at the rationale for SmartArch. In simplest terms, we use arch wires and brackets to place forces on teeth in order to move those teeth. We assume because we use light wires that we're using light forces. Are we actually using light forces? The amount of force required to move a tooth is dependent on the root surface area. It takes more force to move a molar than an incisor. So it's really like Goldilocks. We don't want too much force or too little. We want just enough. The optimal force required to move any tooth is the minimum amount of force required, just enough that can be sustained over time. Because teeth are all different, they're each going to have an optimal force value, and groups of teeth will be similar. So optimal forces are different around the arch. We already have bioforce wires with zones of force that differentiate between anterior and posterior teeth. But as you'll see, the force levels that those arch wires produce are acting no better than our conventional niti wires, under or overshooting the forces needed to be effective in moving teeth optimally. This quote from Dr. Parte just reminds us that technology has to work in concert with biology to get the job done. If the applied force is great enough to totally occlude blood vessels and cut off the blood supply, a hyalinized avascular necrotic area is formed. This area must revascularize before teeth start to move. The time that it takes between necrosis and revascularization is what is referred to as the lag phase. Too much force creates all of these unwanted effects. We want to eliminate the lag phase, where tooth movement ceases due to cell death, and for the simple reason that it takes longer. Conversely, if we don't apply enough force and a sustained force, the teeth don't move at all. In these histologic pictures, it is easy to see the comparison between light and heavy forces. But our assumption is that the force is heavy in the top picture. All we really know is that the force is more than what is required to move that particular tooth. And below, rather than saying low forces, we could term this enough force, because we see the extensive cellular response while maintaining a vascular PDL. So the biological goals are the application of ideal force levels. This is a shift because we have been traditionally taught to think that light forces are produced by light or small gauge wires, and heavy forces are produced by thicker, stiffer, heavier arch wires. It is important to mention here that the ideal force on a maxillary central incisor is the same regardless of what size arch wire is being used, and that was how the SmartArch was designed. We commonly think of overstressing a tooth and slowing tooth movement down, but what about too little force? How many teeth does no 1-4 niti actually target? Too little force will not affect a change, and teeth will not move. We want to move all the teeth simultaneously. This is something that up until now has not been possible, and when I saw SmartArch in action, I can tell you, I had not seen anything like it in my 20 years of practice. Why do we want to move all the teeth at once? Well, really, when you think about it, there's no reason not to. Our anchorage considerations will have to be rethought as a result. If we override the force level required to move one tooth, say a blocked out cuspid, for example, as this is very common, the tooth will act temporarily as an ankylosed tooth. We know that ankylosed teeth distort the arch form, and affect the amount and direction of movement of adjacent teeth. So what does that result in? Arch incoordination. So we aren't just unraveling the teeth with initial alignment. Suddenly, it's become very impactful on my ability to resolve the entire malocclusion. Less coordination of the arches means slower resolution of the malocclusion. So the rationale behind SmartArch was to invent an archwire that would produce an optimal force on each individual tooth. So both the 016 and the 1825 SmartArch have the same optimal forces for each individual tooth programmed into them. Ormco's research pathway summary is exhaustive and extensive. They started with anatomical data that is available to us in 3D form and used finite element modeling and mathematical analysis to create averages for each tooth group. Engineering principles were applied in this process to develop a clinical model that met the ideal force levels, and prototypes were developed that could be tested clinically. The archwires underwent friction testing at the University of Alberta, and the MMMT process was developed and refined so that the company could meet manufacturing specifications and demand. The three main factors to consider in PDL stress are interbracket distance, wire material and diameter, and root size. SmartArch is designed to effectively increase the interbracket distance by altering the stiffness of the archwire interproximally to exert the ideal force level for that specific tooth, and it does this regardless of the size of the wire. MMM, or multiple memory materials technology, is the process used to create the SmartArch. Brilliant researchers and engineers designed and tested this process to bring a reliable archwire, an archwire that does something that has never been done, to our clinics. The process alters the composition of the wire in between brackets to mimic a longer interbracket distance in order to control the stiffness of the wire at the bracket interface. Let's take a close look at this graph because this is important. Along the vertical axes are measures of force, newtons on the left, grams on the right. The x-axis delineates zero force. Above the x-axis are maxillary teeth with forces increasing going up, and below the x-axis are mandibular teeth with forces increasing going down. We have a dental chart basically laid out. So you can see we have 4 lines plotted for the maxillary teeth and 4 lines for the mandibular teeth. The red line is the targeted force profile. You can see the blue line that follows the red line so closely. This marks the force levels for a SmartArch for each individual tooth engaged concurrently to allow for most efficient movement. The dotted black lines are representative of the force levels for an 014 NiTi and an 016 Triforce wire. Here we can see that we are not exerting enough force to move molars at all. The force levels exceed that required to move the incisors and is going to create an undesirable lag phase, slowing treatment down. SmartArch force levels target ideal physiologic force levels for teeth, regardless of the dimensions of the archwire. These are the ideal force levels for groups of teeth highlighted in green. Here we can see how an 014 copper NiTi force levels compare to the ideal. We see force levels on the maxillary anteriors that are higher than required and less force than needed on almost all the teeth except lower lateral incisors. The 016 multi-force levels are far below the ideal physiologic forces straight across the board. Only the SmartArch approximates each and every tooth. Typically, we have a diminished interbracket distance in crowded cases, so force levels will go up with the engagement of traditional 014 NiTi. SmartArch is designed to allow us to tailor the force level on each individual tooth and optimize tooth movement by effectively increasing the interbracket distance. Unraveling the crowding will then allow for all the teeth to move simultaneously, something that has never been possible. SmartArch was designed to reduce appointments, wires, and time. I use customized Insignia self-ligating brackets for all of my full fixed cases, And prior to SmartArch, my typical wire progression was an 014 eye tie to an 018 if needed, followed by a custom 1425 copper eye tie, and then into an 1825 copper eye tie. After that, I would start my finishing wires. Now, I simply use an 016 SmartArch into an 1825 SmartArch, and then finishing wires. Just like it says, reducing appointments, wires, and time. But it does more than that. Let me quickly show you a snapshot of a clinical case just to give you an idea of the types of important changes I'm seeing. This is my typical insignia case, started with 016 SmartArch in both arches. My rule of thumb is just that. If you can't engage the arch wire and close the door with your thumb, we coil space for the tooth. So you can see here that I chose to bypass the blocked out mandibular right central incisor. This is the patient at her first adjustment in 16 weeks. An 1825 SmartArch was placed in the maxillary arch, and I reactivated the coil for 4-1, and we started to rotate the tooth with a power chain under the arch wire. I prescribed class 3 elastics full time, as I would in any situation with blocked out mandibular cuspids. The occlusion was disarticulated with band lock. Note the interdigitation of the teeth. It's magnificent. Observe the symmetric uprighting and vertical correction of the cuspids. Look at the leveling we see after 16 weeks with an 016 SmartArch in both arches. The changes really are remarkable. These are all examples of the dynamism of tooth movement which we have never seen because we've never moved all the teeth before. We're seeing more spontaneous resolution with improved leveling, midline correction, molar corrections, vertical discrepancies, arch coordination, basically every area of establishing an occlusion compared to an 014 eye tie. To see more examples of clinical cases, watch part 2 of this webinar series entitled Optimizing the New Super Elastic Multi-Force Archwire Technology. I'm Dr. Sonia Palick. Thanks for listening.